Hello, everyone, and welcome. This is Professor Thayer with you here today to talk to you about functions. Now, we are going to do our functions over 2 different weeks because there's a lot of information here and the concepts might be a little bit new for many of you. So we're going to take it nice and slow so that you can get all of the pieces. So let me go ahead and share my screen so you can see what we're looking at. As usual, you are welcome to follow along. The slides will be available on our Moodle page or Canvas page. So you can feel free to go ahead and join us that way, or you can feel free to follow along with this video. All right, there we go. All right, so this will be the lecture 3 functions, which follows along in your readings on the functions. So the things we're going to talk about are overview of functions and how to define functions. That will be our goals for today. We'll also take a look at the scope of variables, that is where they can be used, and also Python built-in functions, functions that are already available for you to use in your Python. We'll also take a look at fruitful functions as opposed to unfruitful functions, and the stack, that is when an error occurs, what Python is trying to tell you about that. Overcoming sticky points. There are a number of things about functions that can cause continued trouble, and we'll take a look at some of those and hopefully clarify those for you. And finally, we'll tie up some loose ends with the advanced concepts to round out our discussion on this. So as I mentioned, we'll be doing this over a 2-week period. So let's do an overview of functions. What is a function anyways? A function is a block of organized reusable code that performs a single action. Now, that's great, but like, what is this? What is a function in just really common terms? So have you ever used a calculator? Maybe a 4-function calculator, maybe a scientific calculator, maybe you even have one of the TI series graphing calculators. Have you ever used any of the buttons on that calculator that do something besides addition, subtraction, multiplication, and division, like the square root or the square, or y to the x, raising some number to some power, trigonometric functions, sine, cosine, and all of these? These are all examples of functions. When you press that button on your calculator, you're activating a little block of code in your calculator that's going to go ahead and do a calculation of some kind and then send back the answer to you. Well, how do you suppose that code gets in there? Well, it's because somebody wrote a function. Somebody wrote a piece of code that does a specific task. And so you can then use that to repeatedly do a particular kind of calculation and get the answer back. So here is an example of a Python function. This one is not as detailed as some of the ones we've just been mentioning, but we'll start off with some easy ones. This one is called greet, and it will print hello and the person's name. We're not going to worry too much about all the details of the syntax here. We'll get to that in due time. I just want to give you a preview of what it would look like. Here we have a name, and as you might imagine, this function will then greet me by name, and you will write some functions to greet you too. Why are functions useful? In fact, I coded for some 20 years and never wrote a function and had the very same question. They're difficult to learn. It's kind of confusing in the beginning and it feels a little bit awkward sometimes. So why bother? Well, there are a number of things that functions do that is actually really helpful. It can modularize your code. So this means that the same task can be done at multiple points in the program without having to copy the code. So for example, if you wanted to greet multiple times, you could keep copying the greet code, right? But what if you discovered there's a mistake in the code? Then you'd go back and you'd have to change it in every single one, but you could miss one, right? And then it would be corrected in some and not the others, and then somebody might use your code and they didn't know there was a mistake in there, and you can see that quickly there could be a lot of problems. Also, you would have to take up all that space with copying the code. So wouldn't it be better if there were a way to just have one copy of the code so that you could always just keep track of it? You just keep a good copy. If there's something wrong with it, you go in and you fix it. There's one place, and then you know that it's fixed for the whole program and you don't need to worry about it. So that's one very good reason why we should write our code using functions. It also helps us to organize the code. It's much easier to get the big picture of how the program works, and that's because of a lot of the object-oriented nature of Python, but also because of the way you can do your calls for your functions. So what you can do is you're gonna separate out your code for actually programming the function, and then you will have your function call beneath it. So what you can do when you write larger programs, which we'll see as you get into your final project, you would be able to put all of your functions together, and then you would have all your function calls together separately. And so when you need to call your function, instead of having to slog through all the code and then only intermittently have your function calls, you can put all of that up above, and then you have all your function calls right next to each other. And using good names, meaningful names for your functions, you can then easily see what's happening in your code. So it's much easier to see what's happening in the big picture. If there's a problem with something, then you can zoom in by going to that specific function and working on that. And it allows you to move in and out of your code in a much easier way. Another reason why we want to learn how to use the functions is because it allows us to share the code beyond the program in which it's written. It would allow you to do a number of things. So for example, the Python repository has a wealth of code that others have written. We are certainly not the first to be writing code in Python. So it would allow you to make use of code that's already written. We'll be seeing the math library this week, but there are of course many other things that you might want to import into Python and then make use of that code. There is also the possibility that you are needing to use somebody else's code on a project. And so like imagine yourself working in a company, maybe your colleague has written something. So instead of you having to copy and paste it into your program, you can simply just make use of the code that they've written in their scripts. It also will allow you to do the same thing within your code. Maybe you have a whole suite of programs that are working together to do a certain task or to do tasks around a certain theme. And so we're doing drug design, for example. So we have a whole bunch of different pieces of code that do all different things. And maybe we need to repeat a certain kind of a calculation at various points throughout that. So you can simply just put it into a function, and then you can import that function into your current code, and it keeps your code nice and clean, and you can organize it piecewise into bite-sized parts that logically make sense. It also allows you to share your code with other programmers. You would be able to put your code up on the web, and other people would be able to download and install and make use of your code, but you need to put it in the function form in order to be able to do that. So some good reasons why it's a great idea to learn how to use functions. So consider a familiar use of functions. Maybe you have made use of a scientific calculator. This is the picture of the model that I had when I was in high school. And we had this X squared button. You type some number and you press the X squared button and it squares that number. I'm sure you're familiar with doing this. So you would type the value of X, you press the X squared button, and then the square of X would be displayed on the screen. Not surprising, but it has an awful lot familiar with what we are going to be doing in Python. An input value of X would be provided. The calculator would compute the square of the X value, just like Python would be able to do, and then the answer would somehow get displayed for the user. So hopefully now you're convinced that writing some Python functions is a worthwhile thing to learn how to do. So let's get down to the business of actually defining some of those functions. So it's actually pretty simple, and here's an example of our syntax. Functions have two major parts. It's called the header and the body, and this one has a very large header and a relatively small body. But let's take a look at what it's going to be. The header, that's the part up at the top. So the keyword def, see how that's turned this orangey yellow macaroni and cheese color. And then hello, this is the name of the function. So all the rules we learned about variable names apply to function names. So this is the function name, and then the parentheses, and then we would fill in some information that we want to pass to the function. So these are the variables, also known as the parameters. So this is the input to the function. And then the next part we're going to have is what we call the doc string. This is short for documentation string. We will include what we call the signature, and then we will be telling the types of the variables. So this is the type of the input, and this is the type of the output. So notice that the doc string is technically a string, right? It's got these triple quotes around it. So just like other strings, there you need to have quotes. You can do the triple single quotes or the triple double quotes. I recommend the triple double quotes for many of the reasons I mentioned, using the triple for doing the commenting, because basically this is going to be a comment, and then you will put some text in here. So you have to use the triple quotes. This is the syntax in order to be able to put in the doc string. Then finally we get to the body. This is the part that actually contains the meat of your program here, the important parts. This is where things get done. Notice that it's indented relative to the definition line, as is the signature. There's a sequence of statements in here. In this case, we only have 2, but there could be more. And here we're going to have message equals hello plus name, concatenation of string, where name is going to be a string of some kind. And here we will return that message. There will be a sequence of statements, and there's one or more return statements which may be implicit, and we'll have a lot more to say about those return statements coming up. But the return statement signals the end of the function. That's the keeping, and this sends the information back out. So this particular function will be called right here. So this is the hello that will call the function, and then this here is the information that's sent to the function that gets matched up to the parameter. So a little bit more about this function specifications. The signature tells the input and the output types. Now, because it's a doc string, it's actually not executed by Python, but it is still nevertheless an important part of the function. And this is for human readability of the functions to work properly. And we also want to pass on the information about what the inputs and the outputs of the function are. This will help mainly the future version of you, but also anybody else who may be using your code. For a function to work properly, its arguments, which is the input, and what is returned, that is the output, must have the correct types. Python is a dynamically typed language. This means that Python does not check that you actually gave it the type that you said you did. It just assumes that you know what you're doing, and Python's not going to say anything about it until an error occurs. But something could already be going wrong and you just wouldn't know it. So this is why we want to have the type specified so that the user knows what kind of input they should be supplying and what kind of output they can expect. However, when the wrong type occurs, errors or unexpected results may occur. This is likely to occur when you provide the wrong type. Therefore, as the programmer must keep track of the expected types, and we can do that by using the doc string, particularly the signature. The function signature states the types of the input and the output, as well as it also gives a very brief one-liner about what the function actually does. So that brings us here to the doc string. Let's actually just take a closer look at this. The doc string is the comment at the top of the function, which is right here. It contains up to 3 parts. First of all, the signature, and this is the key part. This is arguably the most important, but this is the one that tells you the input and output. Sometimes we just abbreviate this with SIG. You'll see that in some of mine, but it needs signature, the signature types for the input and output. So this one has a string So name is a string, Max, that's my dog, and then an arrow for the output, and then we specify the type of the output, which will be this message here, which is also a string. Then we need to mention any restrictions not evident by the types. Now this one doesn't have any restrictions, but some of the common problems you might have is division by 0. Remember that division by 0 is undefined. Or if there's a restriction to positive or negative numbers, do you agree that if you say that the type is integer, but it could not be a negative number, that int is not sufficient to determine the scope of the problem? Right, the scope of what you could put for the inputs. So you can use the restriction by simply putting something like, if your variable is x, like x must be greater than 0, or whatever it might be. In most cases, you're going to find that it's not going to apply. If you've done some pre-calculus, you'll know that there are quite a lot of problems, the style problems where you can solve for where the functions are undefined and that sort of thing. That's great and that's true, but that's not really the scope of this course. So we'll keep it to some simple things. Avoiding division by 0 and positive and negative numbers would be the kinds of things that you would typically see in this class. If it doesn't apply, which is probably about 90% of the time, you can simply omit it. And then you can put a brief note about what the function does. So greets user using name is our explanation. Okay, please don't write a book, just a one-liner so you get a quick refresher of what the function is about. That's all that's really needed here. So the docstrings and help. Help is a built-in function in Python. You can use the Python help function with the name of the function that you want to find help on, and it will tell you some information for you. It will pull that information from the docstring. So here's our hello function. And so this is going to work for Python built-in functions, but the ones that you make are also going to have the same features. So you need to make sure you use the triple quotes, and you need to place it after the def line. So it should follow directly after, and it should have this triple quote. It should be indented as is shown here. And then it also lines up with the body of the function. We'll see that indentation is going to matter in other ways, but until we get into some of the other blocks, then this is what it's basically going to look like. So you can do help of print. Maybe you want to know more about how does print work. So you go help of print like this, and then it provides you with all of this information. So this is from the docstring that somebody who wrote the print function had included in there. See, it's telling you print the values to a stream or to system standard out by default. Here's some optional keywords that you can use in order to work with print, and so on. There's all kinds of information you can get here. And when we do this with our function, we would say help, and then we provide the name of a legitimate function, which is hello. So then it would say where it's located. It tells us it's in main because it's in our script and it's not inside another function. That's what being in main means. And then it tells us the hello names. This came from the def line, and it also shows us that signature and the rest of the docstring that we provided. So you can see is basically just copying this out to the screen, which can be very helpful if you forget what your function does, and if your code is getting longer and longer, this can be very helpful. There's also function parameters. Parameters of functions are the input variables. The parameters are defined as part of the header, as we've seen. So here is the hello function, and this takes the input called name. So this is our input parameter. Name is the parameter. The way you call these variables or the way that you name them should be consistent with not starting with a numeric value, capitalization matters, and so on. Just the same rules we've learned for naming the variables. The values of the parameters take on are those supplied by the input values from the function call argument. So here's our function call right down here. We have print, and then we have hello, the name of the function, and we have some information here. So the number of things that are supplied here need to match how many variables are accepting the values. A function may have any number of parameters, including none, one, or many. Here we're illustrating one, but there could be multiple here if you have multiple variables up here. Notice that there is an implicit variable assignment here when you execute your function call, and that is that name gets the value of max right here. Notice that there's no line that says like name equals max, right? There's no such variable assignment. Variable assignment happens as part of your function call. Speaking of function calls, let's take a look at those in some detail. This is a cartoon version of my doggy, a greyhound. And a function will not execute unless it is called. This is very important. To call or invoke a function, we would use the function name followed by the needed arguments in the parentheses. But running the function causes the function to execute. It may cause effects, things to happen. If it didn't, then it wouldn't be very helpful now, would it? All functions return something, although some functions return none. We will have much more to say about this coming up. So let's just take a look at a function call. Here we have print. So this is going to print out the result of hello of max. So here's the name of the function, which matches to the name of the function right here. Here's max, which is going to be assigned to the name. And so this function will execute and it's going to get the message here, hello max. And then it will put that into the message. Notice that we're using concatenation here. We had talked about that when we learned about strings and overloading last week. And now we're going to do print hello of max, whatever gets returned out of this. So this is the function call, which needs to run off and get calculated. And then the answer comes back and goes into the print statement, which then prints out the message. So then, now that we have seen a little bit about how to do functions, let's get back to that square root button on the calculator. Write a function square that will take a number to square and print the square of the number. Sample output of the correctly working function is shown below. Be sure to include the test function calls on your script. This question should be solved in Python. So here is the output of the code itself. And you can see that also interactively, I can call the function from here. So here I'm going to call it square of 2, which gives us 4, square of 3, which will give us 9, and square of 4 gives us 16. So you can see that what it's doing is it's simply multiplying this number times itself. So 2 times 2, 3 times 3, and 4 times 4. You should also make sure that you always do put your function calls into your function. So it should do it should be printing out those answers like it does up here, but you can also do this information from your command line in your idle. So here is what our function would look like. Here's our definition line. Here's the name of the function, which was supplied in the question. So we'll call it square, and then we'll take an input value of x. Here's my signature. X will be an integer, and if you take an integer and you square it, is there any way to get anything besides an integer? No. So the output type will be int as well. And so it will print the x squared. So we're going to print x times x, which will give us the x squared. Here we're going to include the function calls for all of our tests. So here we're going to do square of 2, 3, and 4, which gave us the 4, 9, and 16 answers. All right, well, that is going to conclude it for today's lesson. We look forward to talking to you more about functions in our next meeting. Thank you so much, and we'll see you soon.